bisection method using C programming. Consider an example f of x is equal to x cube minus x square minus 1. First, we want to determine an interval containing root. For that, put x is equal to 0, then f of 0 is equal to 0 minus 1, which is equal to minus 1, which is less than 0. If we put x is equal to 1, then f of 1 is equal to 1 minus 1, which is equal to minus 1, which is also less than 1. If we put x is equal to 2, then f of 2 is equal to 8 minus 4 minus 1, which is equal to 3, greater than 0. Since f of 1 is less than 0 and f of 2 is greater than 0, this implies f of 1 into f of 2 is less than 0, and therefore root lies between an interval 1 2. So, first iteration, consider here a is equal to 1, b is equal to 2, then c is equal to a plus b divided by 2, which is equal to 1.5. Now, we want to determine sin of f of c. So, f of c is equal to f of 1.5, which is equal to 1.5 raised to 3 minus 1.5 raised to 2 minus 1. If you solve this, then f of 1.5 is equal to 0.125 and which is greater than 0. Now, from the previous interval, that is from 1 and 2, f of 1 is less than 0. Now, since f of 1 is less than 0 and f of 1.5 is greater than 0, and therefore root lies between 1 and 1.5. For the next interval, second iteration, consider here a is equal to 1, b is equal to 1.5, then c is equal to 1 plus 1.5 divided by 2 is equal to 1.25. Next, we want to determine sin of f of c, and therefore f of c is equal to f of 1.25, which is equal to 1.25 raised to 3 minus 1.25 raised to 2 minus 1. If you solve this, then f of 1.25 is minus 0.6094, which is less than 0, and therefore this implies f of 1.25 is less than 0. Now, from the previous interval, f of 1.5 is greater than 0. Now, since f of 1.5 is greater than 0, and therefore root lies between 1.25 and 1.5. Continuous in this way, we can find an approximate root of this equation by using bisection method. We can stop this iteration when we get the previous successive 2 roots correct up to 3 or 4 decimal places. Now, we are going to apply a C programming to find a root of the given equation by using C programming. Now, first we want to include stdio.h include conio dot h. Now I want to define a function, say float return float f of float x return x star x into x cube minus x square minus 1, bracket completed. Now next void main float, say float a b c integer, we require I and n, integer I n, then clear screen, want to clear the previous output, then printf, we want to display the message, enter your value of initial guess, first initial guess, then second initial guess, say b, then and number of iteration and n number of iteration. Okay. Scanf percent f floating type, so percent f and n is percent d, so and a and b and n, bracket completed. Next we want to check condition whether f of a, if f of a into f of b is greater than 0. In that case bisection method, we want to display the message printf bisection method fails, bisection method fails, and else now next want to determine the value of c, and since we want to move our iteration up to n, so define first I is equal to 1, then while I less than or equal to n, while I is less than or equal to n, find the value of c, which is equal to a plus b divided by 2, a plus b divided by 2. Then if f of a into f of c is less than 0, means what, we want to replace b is equal to c, means what, the root lies in the interval a and c. So we want to replace b is equal to c, else a is equal to c, then a is equal to c. Now we want to increase the value of I is equal to I plus 1, and then we want to printf the value of root, that is c is equal to or you can write root of the given equation by using C programming, percent f is equal to c, bracket completed, then while loop completed, and then print get ch. Okay, main loop is completed. So if we compile this, there are error. There is one error. Printf Tab. Page down, then Alt C, one error, compound statement missing. So, here 0. Now, I want to print root at new line. So, if you compile and if you run program, enter your value of a, b and n, a is equal to 1, b is equal to 2 and n is 5, then we will get our root. Again, if you compile, a is equal to say 0 and 1 and say number of iteration 5, in that case our bisection method is what fails. If we increase the value of n, say n is equal to, if we increase say a is equal to 1, b is equal to 2 and number of iteration 10, then we get the 10 iteration. Now, if you observe here, the last two roots are correct up to 3 decimal places. Again, if you compile and run 1, 2 and number of iterations say 15, then you can observe the last two successive roots are correct up to 4 decimal places. So, thank you.